Alright, so what you have here is a problem that looks complicated because it has t to the fifth on the bottom, but it's really a lot simpler than that. Because we know that we're going to want to set this to a u squared for our substitution. And the reason is because it matches a trigonometric function. So from this, we can gather that we want our u squared to equal a t to the fifth. Now I need to get this u to be to the power of 1. So if I do that, I'll get u t to the 5/2. Okay? If I take the derivative of this piece now, I'll have du equals 5/2 t to the 3/2 dt. Now, I'm going to want to get this dt by itself, so that way I can replace it with the dt in our equation. So when I move these pieces over to the other side, I'll have dt equals 2/5 t to the negative 3/2 du. So we'll take this piece, this dt right here, and plug it in to the original dt. What we'll get in our substitution is t to the 3/2 times 2/5 t to the negative 3/2 du all over, and I'm going to plug in this u squared for this t to the fifth. So we'll get 1 minus u squared under the radical. Now if you look in this integral right here, you're going to see that this t right here is going to cancel off of this t because it's just the inverse of it. It's to the negative. So these will cancel off to become 1. And what we're going to end up with is a constant right here that can be pulled out into the front. So say 2/5 times the integral of du over 1 minus u squared all under this radical. Now this integral we have right here is actually pretty simple to figure out. It's really the base of a trigonometric function, or a trig identity for integrals. And the trig identity of this one is the inverse sine. And we're doing it of u. Bring out our constants and add another constant, because it's not a definite integral, it's an indefinite integral. We don't have anything starting or ending with it. So then now what we need to do is replace our u with what we had for u in the beginning. So we get 2/5 inverse sine of t to the 5/2 plus some arbitrary constant. So this should be your answer. I hope my explanation helps you out.